So we're talking box and whisker plots, and we got this pretty little kitty up there, and we got a couple of things that we really want to make sure we discuss. And the easiest one, probably to get started with, is the lower boundary, the lowest boundary, the LB. So this is the smallest number in the set, and we put this all the way over here on the left. Now, typically with a box and whisker plot, there's a line that comes off of this, okay? I'm just kind of using the whisker here because I wanted to associate this with the fact that it looks like kind of like a cat's face, right? The upper boundary is on the right side. So way over here, it's the highest data value. And again, it's usually connected with a straight line, not a cat whisker. Now, when we see these, the size of this line does not matter. Sometimes this line is very, very small, and the lower boundary could be really, really close to that. It's just a matter of where this data value falls, and we'll talk about that in a second. Now let's get to the parts of the rectangle here. So we have a left side, a right side, and then a line that's sometimes in the middle, but doesn't have to be in the middle. So let's talk about the Q2 first, the second quartile. So this one right here in the middle. This is the median, all right? So we've talked about this. It's when you have them all in order, which one is exactly in the middle. And so the middle of data doesn't always have to be in the middle of the box. Sometimes the middle could be a little bit further this way if more of your data values are to the left. Sometimes it could be a little bit this way if more of your data values are to the right and a little bit higher. So once we have the data in half, then we can actually find half of a half, okay? So that's what we consider quartile 1. This is the middle of the lower half. So from the middle here to the middle of the lower bound and the Q2. So we're doing like a second middle. And we call that the first quartile because when you read it, it comes first. So this comes first because it's on the left. And then the third quartile is the middle of the upper half. So this one's all the way over here on the right. It's obviously closer to the upper boundary. And, oops, let me get this out of my way. And this line here represents the middle of the upper half. So in between Q2 and the upper boundary. Okay, so we're doing the median twice. Now we got to find this one first before we can find Q1 and Q2. So it's not in numerical order, which sometimes can be a little tricky to understand, but once we do it a few times, you'll get the hang of it, okay? So our learning target for today is to be able to construct a box and whisker plot from a set of data. Just given some numbers, can you make one of these on your own? So this is another visual representation of how data is distributed and comes in the form of a box and whisker plot where we're dividing up the data to show it in quarters or in quartiles. So quarters or quartiles. That's where that word comes from. So here we go with 16 scores that students received on a math quiz. Good news is they're all in order. And that's what it's going to have to be in order for us to construct a box and whisker plot. So the lowest number is 52, the highest is 98, and the first question says, what is the median? Okay, so I'm going to go with my highlighting feature here because we're asked to find the median. Now this is also known as the second quartile, but it's the place that we should start, okay? So let's start with the middle. Out of 16, the middle is going to be between the 8th number and the 9th number. So 1, 2, 3, 4, 5, 6, 7, 8 right here, okay? So it's in between 73 and 74 because there's 8 numbers on both sides. If you don't believe me, count to the right from that middle line, 1, 2, 3, 4, 5, 6, 7, 8. There's 8 numbers. So what do you do if the median is in between 2 numbers? Add these together and divide by 2, you'd get the average. So I'm going to do it that way. 73 plus 74 divided by 2, you're going to end up at 73 and a half. So again, you're just finding the middle between these. So now that we've got the middle, now we can split the first half into 2. So we're going to do that. And that is called the first quartile, which is the median of the lower half. So remember, we've got 8 numbers on this side, 8 numbers to the left. So we're going to count 4 in. 1, 2, 3, 4. So again, it's in between 66 and 68 because there's 4 on this side. How do we find the middle? Well, obviously the middle between 66 and 68 is 67. That's easy. So you could put 67, but I'm just going to show you the more technical way where we would add these two numbers, divide them by 2, and the average of these would be 67. But you know that just by looking at it, okay? So the Q1, 67. Now we got to do it another time. We're going to find the middle. Let me go with another color. The median, that is, of the upper half, or the third quartile. Again, we split this up into 8 and 8. So the middle of the upper half is going to be 4 numbers in. 1, 2, 3, 4. So again, right here. And hopefully you know that that is going to be in between 82 and 84. So to find the average, it would be to add these two and divide by 2. But you know this to be 83 anyways. Nice job, Andrew. So you're doing it in your head. You're just using common sense, which is a fine approach. But just in case it was a little bit more difficult, I wanted you to have that strategy. All right, last one is the range, and this should sound familiar. So the range we know is the difference between the highest and the lowest. Remember that the definitions are built into the questions. So if you have trouble on your practice assignment, make sure you go back and look at these examples. So the highest, 98, the largest data set, also known as the upper bound, biggest number, minus the lowest number, which is 52, also known as the LB, or the lower bound. So go ahead, do a quick little subtraction. Nice, 46 as your range, okay? So we talked about it with the histograms last time. We've got to try to figure out an appropriate interval, okay? Our lowest data value is 52. Our highest is 98. So basically, we got to go from 50 to 100. Now, I've got you a little line down here with some tick marks on it. Let's count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 tick marks. So if we went by 5, 5 times 15 would be 75, which would be plenty to fit in 52 to 98. Now, we don't want to put the actual data values on the line. We want to put multiples of 5, multiples of 3, something like that. So we're not putting the exact data values on this line. So we got to go under 52. You could start at 50. I'm going to play it safe and go 45. I feel like I have plenty of room to do that. And then I'm going to count by 5s. So again, this is not appropriate to put the data values down. You're just going to put down intervals to represent the values that we will eventually put down in the chart. Okay, so I was able to get up all the way to 110, which I don't need, but that's okay. All right, of 73 and a half. So I'm going to put at 73 and a half a vertical line that doesn't touch. It's up above it right here. Okay, so that's the middle, the median. Now I need the first quartile, which is again represented by another line, and this is at 67. So 67, somewhere between 65 and 70, another vertical line of the same size off of the line. And then we get to 83, which is our third quartile, somewhere between 80 and 85, a little closer to 85, same size line. Once I get those 3 down, I make the box. Okay, so the lowest was 52, which we see right here. So 52, somewhere between 50 and 55, and the highest was 98, somewhere between 95 and 100. And then we do draw a line, straight line, to the dot to represent the upper and lower bound. Don't always think of multiple choice as a situation where you don't have to show any work. Here we have to find the box plot, all right, box and whisker plot, also known as box plot, that has the greatest median, okay? So let's go ahead, and if it's just the median, this is the Q2. This is the line in the middle of the box, okay? So all of these are representing the Q2. And you can see that we got to pay attention to the intervals because they're all a little bit different. This one's going by 20 to 40. This one's going by 5s. So this one would be 30. But that doesn't mean that's the highest. Let's try to find the next one. This one looks to be going by 10s. So this right here would be 40, which is bigger than 30. So this one is out. Over here, we're going from 10 to 20. This one's going by 2s. So this is 22. Number 3, you're out. And then this one is going from 5 to 10. It looks like it's going by 1s. So this would only be 7. So that is not bigger than 40. So here it is. So yes, this line is probably furthest to the left than any others. Maybe this one, but again, it's all about how you break up the data. We've got the ages of 15 employees of the Red Hook Curry House. I'm not sure what that is. Sounds interesting. And we want to do everything. So this is really kind of taking off the training wheels, and you've got to put everything together. Now, the data values are in order, which is awesome, and there is an odd number, which we also like because there's going to be a middle. All right, so 15, what's the middle of that? The 8th number. We'll put 7 on both sides. So 1, 2, 3, 4, 5, 6, 7. That makes 26. I don't have to do anything funny. The middle, because there's 1, 2, 3, 4, 5, 6, 7 on this side. So we got to find the Q1, the Q2, and the Q3. This is the fastest way to write it. 26 is our middle. All right, that is the median of the whole data set. Now let's go ahead and do the other quartiles. Now I said 7, right? So that means that the middle number here is going to be 3 in. 1, 2, 3. So 18, because there's 1, 2, 3 on this side. So the Q1 is 18. And then we do the middle of the upper half. And again, that's going to be the 4th number in. 1, 2, 3, 4. Because then there's 1, 2, 3 on this side for 37. So the LB and the UB. Well, the lowest number in this data set is 16, with the highest number at 44. All right. Now we want to create a box and whisker plot. Now, I don't even give you a line, so we're going to have to really do this from scratch. So draw a line, straight as can be, add some tick marks in. We want to go from 16 to 44. It's up to you how many you want to do, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe 11 would be good for me. And I got to go from 16 to 44. So I'm thinking by 3s. And again, this is up for your interpretation. You can go by 2s. You can go by 4s. You can go by 5s. Just don't go too big and put the data too close together. So I'm going to go by 3s just to show something different. 18, 21, 24, 27, 30, 33, 36, 39, 42, 45. And I've done it. I've been able to capture the lowest number and the highest number. And again, you don't put the actual data values on your line. So constructing this puts a line in the middle at 26. I always like starting with that middle line. And then the first quartile was 18, right here at the tick mark. And then we had 37, so right here. Go ahead and make your box. Now that your box has been constructed, we're going to go with the lower half. So a dot for the lower, just inside of 15, connected to the box. And then the upper one just inside of 45 and connected. So there it is, your box and whisker plot. Our actual physics teacher here, Mr. Cox. And let me tell you, what a great class, what a interesting character. Definitely represents a physics teacher to a T. Hopefully you guys can take that class by the time you're a senior. The results of his quiz are shown in the box and whisker plot below. Assume that all scores are whole numbers. What was the median score of Mr. Fox's physics quiz? Median, as in the middle, as in Q2. Right here, Q2. And this looks to be going by 2s, but this one's in the middle of 70 and 72, making this 71 for a median. How about the range? Well, the range is the difference between the highest and the lowest. So going by 2s puts this at 84 and puts the LB at 53. So just reading this data, 84 minus 53 would be the range. So to find the range, you would have ended up at 31. 75% of the data would be the third quartile breaking it up into quarters, so that would be 76. And then the lowest quartile would